Now we are going to discuss about the Faraday law and calculation of the Faraday law. So here this is a very difficult part, but very simply you can understand what is here. So first we try to understand what about the Faraday law says. So there is there is two Faraday laws about electrolysis. So you can see here now what about the definition for this two law and first law. They said first law said the amount of chemical reaction which occurs at any electrode during the electrolysis by a current is proportional to the quantity of electricity passed through the electrolyte and solution or melt. And the second law says the amount of different substance liberated by the same quantity of electricity passing through the electrolytic solution are proportional to their chemically equivalent weight or atomic mass of the metal or number of electron required to this one. So this is the definition of this Faraday law. But when considered by this Faraday laws, it is very difficult to understand what say. So I am going to explain how we can understand simply what say. So when considered first law says the amount of chemical reaction which occurs at any electrode during the electrolysis by a current is proportional to the quantity of electricity passed through the electrolyte. So when considered about this one, simply it says like this. Simply it says when we consider about the current and time and the quantity. Quantity means normally we discuss about quantity or Q equal IT. So this is the first process about this equation, and first law says about this equation Q equal IT. Q equal IT means here Q is the charge equal current time. So this is the first law. Simply first law says about this one. So when we consider about the first Faraday law, this is simply, and also you can understand when consider about this Q should be proportional to mass. Mass means when consider about the electrolysis process, there is a dissolution or deposition of material. So therefore when consider about this one, you can understand Q directly proportional to mass or deposition or dissolve. So this is the first law, simply says about this one. So try to understand here Q is the charge. When consider about unit, charge of the unit is coulomb, capital C, and the current is ampere, and time should be in second. So you have to use this unit and also use this equation as first law of the electrolysis. So simply try to understand this one. Let's consider about the second law, but when consider about this part, it is simply says for the oxidation or reduction process, the 1 mole of electron should require 1 Faraday constant amount of the charge. So when consider about this one, 1 mole required 1 F. Here 1 F means it is related to there's a calculation, but here you try to understand 1 F equal 96,487 coulomb. So this amount of charge should required for the oxidation or reduction process of the electrolysis process. So when consider about here, simply we can understand 96,487 coulomb per mole. This is the amount required for oxidation or reduction process for 1 electron mole. So when consider about oxidation process of sodium convert into sodium plus by removing 1 electron. So very simple. So for this one, the amount required to for the electrolysis process of the charge, it is equal to 96,487 coulomb or 1 Faraday. So when considered magnesium convert into magnesium 2 plus by removing 2 electrons. So here 2 electron more, therefore we should 2 times 96,487 coulomb or 2F. Okay, so when consider about aluminium convert into aluminium 3 plus by removing 3 electron. So here it needs 3 times 96,487 coulomb or 3F. So likewise for a chemical reaction you should be able to understand what is the amount of Faraday constant required for the process. So simply you can understand what is the amount. Okay, so but this 96,400, so generally we use for our convenience it is used as 96,500 sometimes, but if they have not given, you have to use the exact value. So when you read the question, try to keep it in mind. Okay, so this is the only part you have to keep in mind for the calculation of the electrolysis with the Faraday law. So this is 96,400 coulomb per mole and Q proportional to mass. So now let's see how we can do example question for this type of one. Then we try to understand how we can manage this type of question. Now we go for the question. Now here you can see the question number 1 and this one. Let's consider about question number 1. A student with titanium cell using half cells, copper and zinc, and a current of 0.5 ampere is produced for 22 minutes. Predict the mass of zinc oxidized to aqueous zinc ion. So you have to find the amount of dissolved amount, so you have to use the Faraday law. So let's see how we can use the Faraday law for the calculation of this type of question. So first write this question in your note and then try to understand how we can do the calculation for this. So first here we have to understand what is the point, and here first find what is the current equal 0.5 A, current equal 0.5 A, and time equal 22 minutes or 22 into 60 seconds. So current and charge okay, sorry, current and time okay. Then you have to find what is the mass. So for this one, first get I and then find what is the charge in Q. 60 coulomb, 660 coulomb. Then you have to find a mass. For the mass they ask about what is the predict the mass of zinc oxidized to aqueous zinc. So zinc, so mass mean you have to find, then the conversion is the Q proportional to mass. You have to use this one, Q proportional to mass. Then this coulomb, so now we know 96,500 coulomb related to 1 mole, then means 1 mole related to then 96,500 coulomb related to 1 mole, and then you have to find 660 coulomb related to what is the amount of mole. Okay, then you have to find what is the amount of mole. 660 coulomb related to amount of mole. Now let's see what you can do for the calculation. So we got the calculation 9600 96,500 coulomb related to 1 mole. Then you have to find 660 coulomb related to what is the number of mole, and this is the calculation. And when consider about the equation, so we have to consider what is the dissolution equation here. So when the dissolution, zinc convert into zinc 2 plus by removing 2 electrons. So here you have to consider about these 2 electrons. So if we use 1 electron, it is 96,500. Okay, 1 Faraday. So this is 1 electron related to 1 Faraday or 96,500. So here it should be 2 electrons. So therefore 2 Faraday, then you have to get the exact value 2 times 96,500. So they have to, therefore you have to rearrange above calculation like this. 2 times 96,500 coulomb related to 1 mole, and 660 coulomb related to what is the amount of mole. So you can easily do the calculation. 1 over 96,500 times 2 equal 660 coulomb. So this is the number of zinc mole, and this is then you can find the mass. Zinc mass equal 1 over 96,500 over 2 into 660 times this is the molar mass of zinc, 65.4 grams. So this is the final mass of the equation. So you have to get the calculation, so you can get the answer as like this. Final answer is, so you can get the mass like this: 1 over 96,500, 1 over 2, and 660, and this is finally 65.4 gram, and then you can get the final mass. It is about 0.224 gram. So in the question sheet, in the left right side, they have given the answer for other question also. So same type of question, only thing they ask about Q or number of charge or current or time or mass. So you can do other questions. So try to do other questions at home. In the video I will give these questions as a small time, so you can write all the questions and you can do, and the only thing you have to use this type of calculation. So try to do that all other questions, and if you have any question, just try to contact me and I'll help you. Okay.